In section 6.1, we look at the parabola. We have some experience graphing parabolas, but this is a more detailed look at the parabola. Let's start with the definition. A parabola is the set of all points in a plane such that the distance of those points from a fixed line is equal to the distance of those points from a fixed point. The fixed line and the fixed point, which lie in the plane of the parabola, are called the directrix and the focus, respectively. Okay, so the basic situation is we have some given line, which would be this line here in the graph, and this line is called the directrix. And then we have a given fixed point, which is what we call the focus. And the parabola is the set of all points which end up making this shape. And the significance of these points is that if you pick any point on this parabola and you find the distance from that point to the focus and the distance from that point to the directrix, those two distances are equal to each other. So if I call this D1 and I call this D2, D1 is equal to D2. And it doesn't matter where we choose the point. So if I pick another point on this parabola, let's say this point here, the distance between that point and the directrix is this distance here, and the distance between that point and the focus is this distance here. And if I call this distance D3 and this distance D4, D3 is equal to D4. So it's the set of all points such that the distance between those points and the fixed point is the same as the distance between those points and the given line. That's the official definition of a parabola. What I would like to do next is talk about the derivation of the formula for a parabola. So as we mentioned previously, here we have a set of points, and those points are the same distance from a given point, which we call the focus, and a given line, which is called the directrix. And for simplicity, we're going to assume that the vertex of our parabola is at the origin 0, 0. Now what we know is the distance between point F and point P is the same as the distance between point P and point M. So to derive the formula for a parabola, we say the distance between P and F is the same as the distance between P and M, and then we use the distance formula to calculate these distances. So the distance between the points P and F, if we use the distance formula, remember the distance formula says that you take the square root of x2 minus x1 squared plus y2 minus y1 squared, right? And that's where you're given 2 points, x1, y1, and x2, y2. This is how you find the distance between those 2 points. So for point F and point P, we are taking the point 0, P, right? So that represents the focus. And then we're taking any point on the parabola, which we're calling x and y. And the distance between those 2 points, if I apply the distance formula, is x minus 0 squared plus y minus p squared, and then a big square root around it. And if you simplify this here, x minus 0 squared is x squared, and we end up with this distance here. Then we do the same thing for the distance between point P and point M. Now again, point P is represented by the coordinates x and y. Point M is a point on the directrix. Now we know the x-coordinate for point M will be the same as the x-coordinate for point P, and the y-coordinate is negative P, okay? And that's because since we know the directrix is the same distance away from the vertex as the focus, if the focus has coordinates 0, P, the directrix here has to be P units on the other side. So we know that this is y equals negative P, which means every point on this line has a y-coordinate of negative P, And then as I mentioned, the x-coordinate here has to be the same as the x-coordinate here, and we're calling both of those x. All right, so the distance between point P and point M, we're going to subtract the x-coordinates, which is x minus x squared. And then we're going to subtract the y-coordinates, that's y, take away negative p squared. This, of course, is 0, and this becomes y plus p, and we end up getting this expression. And then what we know is this distance is equal to this distance. And that's what we have down here. We set those equal to each other. And then what you can do here is you can square both sides, and that makes the radicals go away. And then in addition to that, after you remove the radical, you can multiply this out, which gives you this expression here. Multiply this out, which gives us this expression here. And then we can solve for x squared. So just notice that if you subtract y squared from both sides, those go away. If you subtract p squared from both sides, those go away. And then if I add 2py to both sides, we end up getting x squared is equal to 4py. Okay, so you don't have to memorize the derivation of this formula, but you do need to know this formula. So again, let's go through the important things about this formula. So if you have a parabola where the vertex is at the point 0, 0, and the focus is p units away from the vertex, which means its coordinates would be 0p, the formula for the parabola is x squared is equal to 4p times y. So notice that the equation for this parabola is only dependent on p, and p is the distance between the vertex here and the focus here. So as long as we know that, we know what p is, and we know the equation for the parabola. Now let's take a look at a summary of the equations and graphs of parabolas. So the one that you see here is the one that we just talked about. We have a parabola opening upward. The vertex is at the origin. The focus has coordinates 0p. The directrix is the equation y equals negative p. And we know the equation for that parabola is x squared is equal to 4py. Okay, and you can see that here. Likewise, if the parabola is opening downward with a vertex at the origin, and if the focus is still 0p, where now p is a negative number, the equation actually turns out to be exactly the same. X squared equals 4py. So if you have a vertical parabola, whether it opens up or whether it opens down, the equation for that parabola is the same. It's x squared equals 4py. What determines whether it opens up or down is whether p is positive or negative, and we'll talk about that some more in examples. Now, if you have a parabola opening to the right or a parabola opening to the left, the idea is exactly the same, except now the focus is at p0 instead of 0p, because it's opening sideways. And so the roles of x and y simply get reversed. So if you understand that here the equation is x squared equals 4py, then you should understand that here the equation is y squared equals 4px. And then there are two scenarios here. We have the scenario where the parabola opens to the right and the scenario where the parabola opens to the left. And what determines that is the value of p. If p is positive, it opens to the right, and if p is negative, it opens to the left. Okay, and all that is summarized here. Now, one final thing to talk about is the axis of symmetry. The axis of symmetry is just the line that cuts the parabola into two equal parts. So I want you to notice that for the first two parabolas, this right here is the axis of symmetry, and that is the y-axis because that cuts the parabola into two equal parts. So you can see that down here. And for a sideways parabola, the axis of symmetry now runs this way, and this is the x-axis. Okay, let's take a look at an example. In our first example, it says, consider the parabola with the vertex at the origin defined by the equation y equals 1/6 x squared. They want us to find the coordinates of the focus, find the equations of the directrix and the axis of symmetry, find the values for A, at which the point A4 is on the parabola, sketch the parabola, and indicate the focus and the directrix in that sketch. Okay, there's a lot to do here. First thing you need to determine is what type of equation are we looking at? So let's remember that there are two possibilities here. The equation can either be x squared equals 4py, or it could be y squared equals 4px. So which one do we have? Well, our equation has an x squared in it. You can see it right there. So that means we must be talking about x squared equals 4py. So now what we need to do is take our equation and make it look like x squared equals 4py. So in other words, what we need to do here is solve for x squared. To do that, I'm going to multiply both sides by 6. That's going to cancel the 6 here, and that leaves us with 6y is equal to x squared. Or if you like, you can write that as x squared is equal to 6y. And now because we know that the standard equation is x squared equals 4p times y, you can see that 6 must be the value of 4p. So that means that 4p has to be equal to 6, and if we divide both sides by 4, that allows us to solve for p, which is 6 over 4, or 3/2. Now that we have the value for p, we have to think about what does this mean? So what are the coordinates of the focus? Well, let's think about what the graph looks like. Because the equation is x squared equals 6y, we know that this parabola has to open up or down. Because the value of p is positive, we know that this parabola opens up. So let's think about what the parabola looks like. The vertex has to be at the origin, and remember the value of p tells you how far away from the vertex is your focus. 3 over 2 is 1.5 units. Since the parabola opens upward, it must look something like this. The focus is always on the interior of the curve of the parabola. So the focus has to be here, 1.5 units away from the vertex. The directrix has to be on the other side, the same distance away. So the directrix is this line, and the focus is this point, which I should label F for focus. So now, what are the coordinates of the focus? We should be able to give that now. The coordinates of this point are x equals 0 and y equals 3/2. So for part A, we can say the focus has coordinates 0, 3/2. For part B, it says to find the equations of the directrix and the axis of symmetry. Well, the directrix is this line. That's a horizontal line, so we know it's going to be y equals, and then we just have to give the y coordinate, which is -3 over 2. So that's the equation for our directrix. And then again, your parabola opens upward like this, which I haven't drawn yet, but the axis of symmetry is going to be here. Notice that the axis of symmetry has to go through both the focus and the vertex. So it's this line right here, and that line is the y-axis, or we can say that's the equation x equals 0. Now, let's go ahead and sketch the parabola. To sketch the parabola, we just need a couple of other points on the parabola. So if I know the equation is x squared is equal to 6y, all I need to do is plug in a couple of values for x to find a couple of additional values for y. And you can pick any points that you like. we already know that when x equals 0, y equals 0. So now I want to pick a value for x that's easy to plug in. So an easy value would be if I pick x equals 6. The reason I'm picking 6 is because I can see a 6 here. So notice that if x equals 6, that gives us 6 squared is equal to 6y, which says 36 equals 6y, which means y equals 6. So if x equals 6, y equals 6. But also, if x equals negative 6, we would get y equals 6 because negative 6 squared is also equal to 6y, and that gives us 36 equals 6y, and once again, y equals 6. So we get two additional points here. The point 6, 6, which is this point, and we also get the point negative 6, positive 6, which is this point. And then we can sketch the parabola. The parabola just goes through these points, so it curves something like this. Now, before we actually sketch the graph, let's find the value for a, for which the point A4 is on the parabola. So if the point A4 is on the parabola, A4 means that x is equal to a and y is equal to 4. And in our equation, x squared equals 6y, this would be a squared is equal to 6 times 4, if I just plug in the values of x and y, right? If I plug those in, that's what I get. And that says a squared is equal to 24, and then that means that a would be plus or minus the square root of 24. So when y equals 4, the values for x would have to be plus or minus the square root of 24, which can be simplified as plus or minus 2 radical 6. If you plug that into a calculator, you get plus or minus 4.9. So when x equals 4.9, which is right about here, the y value is 4. Okay, that's this point. And when x equals negative 4.9, which is over here, the y value is also positive 4. And that is this point here. And now I feel confident that I can sketch the graph of the parabola. It goes something like this. And now I believe we've done everything. So before we do another example, let's just kind of summarize what we talked about here. Basically, you have two different situations for equations for parabolas. You have parabolas that can open up or down, and that's given by basically this graph here. And you have parabolas that can open to the right or to the left, and that's summarized by this graph here. And there's some observations that we want to make, a couple of which I've already mentioned. So first of all, notice that the parabola always opens toward the focus and away from the directrix. So the focus is always on the inside of the parabola. It's on the part toward which it curves inward. So the parabola opens this way, that is away from the directrix and toward the focus. And the same thing is true over here. This parabola opens toward the focus and away from the directrix. The axis of symmetry of the parabola is always perpendicular to the directrix. So here's your directrix here. Notice that the axis of symmetry is perpendicular to that. And over here, here is your directrix here, and the axis of symmetry is perpendicular to that one as well. The axis of symmetry intersects the parabola in one and only one point, the vertex. So the axis of symmetry passes through the vertex. The focus is not considered to be part of the parabola. Yes, it's important in determining the parabola, right? But the parabola is only this part. It's the curved part of the graph. The focus is a reference point, and the directrix is a reference line. The directrix does not intersect the parabola, and it is not part of the parabola. The focus lies on the axis of symmetry, but is not part of the parabola, as I just mentioned. And finally, if a parabola opens to the right or to the left, the variable y in the equation is not a function of x, since basically it does not pass the vertical line test. So if you imagine drawing vertical lines over here, you can see that a vertical line is going to intersect this graph twice. That means it's not a function technically. Whereas for a vertical parabola, they are functions because when you draw vertical lines in a parabola that opens up or down, you only hit the graph one time instead of twice. So those are just some summary observations of parabolas. Let's take a look at another example. In the second example, it says to determine the equation in standard form of the parabola with the vertex at the origin and the directrix at the line x equals 3. Sketch the parabola and indicate the focus and the directrix. Okay, so we want to find the equation of the parabola here. Notice that the vertex is at the origin and the directrix is at x equals 3, this line here. That means that this distance here is 3 units. So the focus has to be on the other side of the parabola, and it must also be 3 units away from the vertex. So if that's 3 units, we know that the coordinates of that point must be -3, 0. So the focus must have coordinates -3, 0. Also, we know that this distance, this 3 units, has to be the value of p. So we know that p equals 3. And we also know that since it is opening to the left, p has to be negative. So actually, I need to correct that. P has to be -3 because it is opening to the left. Okay? And finally, what is the equation of the parabola like? Well, in the previous problem, we had x squared equals 4py, but that's for a parabola that opens either up or down. For this parabola, it's going to be y squared is equal to 4px. So this is the correct equation. So what is the equation going to be? Well, we know that p is -3, so all we have to do is plug that in. And if we do so, we get y squared equals 4 times -3 times x, and that says y squared equals -12x. So here is the equation of the graph that you see here. And in that graph, here is the focus. And the coordinates of the focus are -3, 0. Now we're going to add one final twist to our whole discussion here. What happens when the vertex of your parabola is not at the origin? So let's assume the vertex of your parabola is at some point which we will call hk. What is the equation of that parabola going to look like? Well, we already know that if a parabola opens upward, the equation is x squared equals 4py. And this is when the vertex is at the point 0, 0. So all we're doing here is we're shifting the vertex so that instead of being at 0, 0, we're shifting it h units horizontally and k units vertically. So all I have to do is replace x with x minus h and replace y with y minus k. So if you do that, you get x minus h squared equals 4p times y minus k. And that's the equation of a parabola when the vertex is at hk. And you can see that right here. So if you take that argument and apply it to all of these situations, you'll notice that when you have a parabola that opens either up or down, its equation is given by x minus h squared equals 4p times y minus k. And if you have a parabola that opens to the right or to the left, basically you just interchange x minus h becomes y minus k, and y minus k becomes x minus h. Everything else is pretty much the same. Let's go ahead and take a look at an example. In this example, we want to determine the equation in standard form of the parabola with directrix y equals 7 and focus at the point -3, +3. So the first thing I'm going to do is graph the directrix and graph the focus to give us a feel for what we're looking at here. So the directrix is y equals 7. Y equals 7 is a horizontal line that passes through 7 on the y-axis. This is our directrix. And the focus is at the point -3, +3. -3, +3 is right here. That's the focus. So the first thing I need to do to find our parabola is I got to find the vertex. But we know the vertex is always exactly halfway in between the focus and the directrix. So the vertex has to be at this point right here. And the coordinates of that point is -3, 5. So the vertex has coordinates -3, 5. Now the other thing that we know from this is that this parabola will be opening down, right? It has to look something like this, opening down, because it always opens toward the focus. So this is a downward opening parabola. If a parabola opens downward, we know its equation is x minus h squared equals 4p times y minus k. And then we know the value of h is -3, and the value of k is +5. And so what I can do is substitute those values in here. We have x minus -3 squared equals 4p times y minus 5. So this is x plus 3 squared equals 4p times y minus 5. Now the last thing we need to do to find the equation of this parabola is we have to determine the value of p. Well, again, the value of p is the distance between the vertex and the focus. So this is the value of p. So this distance here is 2 units. However, since it's opening downward, we know that p has to be -2. So now all I have to do is plug in the value p equals -2, and that gives us x plus 3 squared equals 4 times -2 times y minus 5. And that says x plus 3 squared is equal to -8 times y minus 5. This is the equation of that parabola. Now let's sketch a graph. And for this, I want to tell you about a little trick for sketching the graph of a parabola. The trick is to look at the value of 4p, which in this case is -8. Ignore the negative. If you just take the value 8, when you come up to your parabola at your vertex, you know it's going to go out this direction and this direction because it's opening downward. The significance of the number 8 is that if you go to your focus and you go 4 units to the right and 4 units to the left, notice that that gives you a total of 8 units across. We know the parabola is going to pass through these 2 points. Okay, so that's a little trick for getting a couple of points on your parabola quickly and easily and without having to do any computations. So again, that distance, the distance straight across here through the focus from one side of the parabola to the other, that distance is 8 units, and that comes from this number right here. And this is always true about parabolas. In the next example, they ask us to find the vertex and focus of the parabola defined by this equation. And just a quick note, we'll need to complete the square to do this. So if I want to find the vertex and the focus, the first thing I need to do here is put it into the format of standard form. And we have 2 possibilities for this. It's either this one here, and that's for a vertical parabola, or it's this one here, and that's for a horizontal parabola. So which one is it? Well, if you look at your equation, you can see you have a y squared, but you do not have an x squared. So it cannot be this one, because that would have an x squared. It has to be this equation here. So we're going to take the equation that was given to us, negative 4x plus 3y squared plus 12y minus 8 equals 0, and we're going to put it into this form. So I'm going to move all of my x terms and constant terms to the right side of the equation. This will give us 3y squared plus 12y is equal to positive 4x plus 8. So please note that I'm just adding 4x to both sides of the equation, and I'm adding 8 to both sides of the equation. And then we need to complete the square here. So to do that, I'm going to factor out a 3, which gives us y squared plus 4y. Leave a space for completing the square. And then you have to remember the completing the square process, which involves taking the middle number, 4, dividing it by 2, and squaring it. That number is 4. So I need to add 4 here, and I need to add the same number to the other side. But remember that this 4 is actually multiplied by 3, and 3 times 4 is 12. So I need to add 12 to the other side. So now what I have is 3 times y squared plus 4y plus 4 is equal to 4x plus 20. And we're almost done putting it into this form over here. All I need to do is factor this. So we have 3 times y plus 2 quantity squared equals, factor out the 4 here, we get 4 times x plus 5. And the last thing I need to do is divide both sides by 3. And that will cancel the 3 here. And we end up getting y plus 2 quantity squared equals 4/3 times x plus 5. And now we have the standard form of the equation of this parabola. And now we should be able to easily identify the vertex, the focus, and the directrix. And also, we should be able to sketch a graph. In our next example, we have to complete the square to write the equation of a parabola. So for this equation here, they want us to find the vertex and the focus, and then determine the equation, and finally sketch a graph of the parabola. The first thing to point out is that the standard form of this equation is going to look like this. And I know this because I can see I have a y squared in the equation, but I do not have an x squared. So it must be y minus k squared, right, because that's how you get a y squared, equals 4p times x minus h. So to get the equation, we have to find the value of h, the value of k, and the value of p. So if we take our equation, the first thing I need to do to make this equation look like this is I'm going to move all of my x terms and constant terms over to the right-hand side. So I'm going to add 4x to both sides and add 8 to both sides. And when we do that, we get 3y squared plus 12y equals 4x plus 8. Next, I need to complete the square on the left-hand side of the equation. To do that, we have to factor out the 3 first. So if we pull out the 3, we get 3 times y squared plus 4y. And the other side stays the same. And you'll notice that I left a little space here to complete the square. Next, we have to add the number to complete the square. So you need to remember to take the middle number divided by 2, quantity squared. This is 4. So I need to add 4 here. And on the other side, I have to add 12 because 3 gets multiplied to 4, and 3 times 4 is 12. So to make sure we add the same number to both sides, I have to add 12 over here. Now we're ready to factor. This is 3 times y plus 2 quantity squared equals 4x plus 20. On the right-hand side, I can factor out a 4, which gives us 4 times x plus 5, and we are almost there. So this, notice, almost looks like this, except that there should not be any number outside of here. So I need to divide both sides by 3. And when I divide both sides by 3, I get y plus 2 squared equals 4/3 times x plus 5. So this is the equation in standard form. Now from this equation, we need to extract the values of k, h, and p. So let me clear out some of this here, and we can focus on this equation. So you can see that k is just the opposite of this number here. So that means that k is equal to -2. You can see that h is the opposite of this number here, so that's h equals -5. And to find p, you can see that 4p is equal to 4/3. So that one we have to solve for. 4p equals 4/3. Multiply both sides by 1/4 to solve for p, and that is going to give us p equals 1/3. So now we have the values of k, h, and p. So the vertex has coordinates hk. So for this problem, the vertex is going to be -5, -2. And I'll just make the comment here that sometimes students get these backwards. So the easy way to remember it is the x-coordinate of the vertex should match the number that is next to the x variable, and the y-coordinate of the vertex should match the number that is next to the y variable. But of course, we're taking the opposites of both of those numbers. So the vertex is at the point -5, -2, which is right here on the graph. So I'll put a V for vertex. And now we need to determine where is the focus and where is the directrix. So for that, we need to know which way does the parabola open. Well, P is positive, and it is a y-squared graph. Well, y-squared graphs open to either the right or the left. But since P is positive, this must mean that it opens to the right. So our parabola is going to open something like this. So that means the focus is to the right of the vertex, and it is to the right by 1/3 of a unit. So if I zoom in here, if I go 1/3 of a unit to the right of the vertex, that is right about there. That's the focus. And the directrix is a line that is on the other side the same distance, and it will be a vertical line in this case. So there's our directrix and there's our focus. Now, if you want to give that more precision, the directrix is the equation x equals -5 1/3, or you can say -16/3. That's the equation of the directrix. And the focus, f, has coordinates. Well, think about it now. This is -5, but the x-coordinate is 1/3 of a unit to the right of -5. So that is going to be -5 plus 1/3, which is -4 2/3, which can be rewritten as -14/3. So the x-coordinate of the focus is -14/3, and the y-coordinate is -2, because these 2 points are on the same level, right? -2. So we have the directrix, which is x equals -16/3, and we have the focus, which is that point right there. And now we just need to graph the parabola, and for that, we just need to get a couple of additional points. Now, an easy way to do that, if you remember from the last example, is I told you there's a trick for that. And the trick is, when you have your equation of your parabola, this number right here tells you the distance across the parabola through the focus to get from one side to the other. Now, again, our parabola opens this way. So that means the distance across from the point over here to the point over here is 4/3. So that means we are 2/3 of the unit this way and 2/3 of a unit that way. So if I do that, if I go 2/3 of a unit this way, that puts us right about here, and 2/3 of a unit this way puts us right about there. Now, I'll admit that this is extremely inconvenient for this example because these are fraction values and this is kind of complicated. So if you don't like that, you can always find additional points by simply plugging numbers in. So for example, what I can do here is make a table of values for x and y. We already know that when x is -5, y is -2. That's the vertex. Now I just need to pick a couple of additional points for x and find the corresponding values for y. And for this, a very convenient value to pick for x is x equals -2. And when you plug in x equals -2, you're going to get two different y values. Now let me explain why -2 is a good choice for x. When you plug in x equals -2 into the equation, you get y plus 2 squared equals 4/3 times -2 plus 5. This says that y plus 2 squared equals 4/3 times -2 plus 5 is 3. So I chose -2 because -2 plus 5 is 3, and that will cancel these out. And more importantly, you'll see that what you have left over is a perfect square, right? See how we got +4 left over there? So now when I take the square root of both sides, we end up getting y plus 2 equals plus or minus 2. So this means y plus 2 equals 2 or y plus 2 equals -2. And that means that y is either 0 or y is -4. And so for that, we can now graph a couple of additional points. We have x equals -2, y equals 0, which is this point right here. And then we have x equals -2, y equals -4, which is this point right here. And now I have a few points, and I could sketch the graph of this parabola, which looks something like this. For our final example, let's consider an example involving headlight design for a car. So we're told the cross-section of a headlight reflector is the shape of a parabola. So basically we have a three-dimensional parabola here. The reflector is 6 inches in diameter, okay, so that's the distance from here to here, and 5 inches deep. That's the distance from here all the way to the back. What we want to do is find an equation of the parabola using the position of the vertex of the parabola as the origin of your coordinate system. So here we have the parabola that opens to the right, you can see there. So the vertex is at the origin and it opens this way. And we know that it passes through the point 5, 3 and 5, -3 because we know that this distance here is 6 units, right? Because they told us that. This distance here is 6 units. And the distance from here to here is 5 units. Okay, so that's this distance here. So that means that this point has an x-coordinate of 5 and a y-coordinate, which is half of 6. That would be 3. And this point has an x-coordinate of 5 and a y-coordinate of -3, right? That gives us the distance 6 here and the distance 5 here. So now using this, I should be able to find the equation of the parabola. Now this is a parabola that opens to the right. So we know that its equation is going to be y squared equals 4px. Note that there is no h or k in this because basically h and k are both equal to 0 since it has a vertex at the origin. And now I just need to figure out the value of p. Now they don't tell us the value of p, which is this distance here. So we have to solve for p. And the way we do that is since we know that the point 5, 3 is on this parabola, we can plug that in. So by plugging that in, I mean y equals 3 and x equals 5. And this gives us 9 equals 20p, or p is equal to 9 divided by 20. And so the equation of our parabola is y squared is equal to 4 times 9 over 20 times x. And this is y squared equals 9/5 times x. So this is the equation of the parabola. And for part B, it says the bulb for the headlight is positioned at the focus. Find the position of the bulb. So the bulb of the light is this thing right here. That is the focus of your parabola, which is this point right here. So what is the position of the focus? Well, we know that the distance between the vertex and the focus, that distance right there has to be p units, right? So we know that this distance is p. but we know what P is. Over here we have P equals 9 over 20. So the position of this focus is the x-coordinate has to be 9 over 20, and the y-coordinate has to be 0. That's the position of the focus.